calculation of velocities of the rigid body. When you say velocities, it may mean angular velocity, it may mean linear velocity. When you say angular velocity, this is for the body. When you say linear velocities, it is for a point in the body. Let us take a point P. Let us assume that velocity of any other point, say center of mass, is given as Vc is given. Angular velocity of the body is given. Let it be clockwise and omega its speed. And the distance between the point and the second point, whose velocity is given, here it is center of mass. For the sake of simplicity, B R. How to find the velocity of this point P? Even though we have two methods, I would like to use a relative motion method. With this method, we can use Galilean transformation of velocity, which states that velocity of P with respect to C, with respect to this point, can be written as velocity of P minus velocity of C. Velocity of P we want, therefore you pull it to left hand side. Velocity of C is given, that is added with velocity of P with respect to C. Velocity of P with respect to C is physically viewed when you climb onto the point C, if it is center of mass, or it may be any other point. When you stand on this point C, you can see that this point moves perpendicular to the line joining these 2 points, that is PC, with the magnitude that's equal to R into omega, because angular velocity of the rigid body is defined as the relative velocity between these 2 points upon the distance of separation, as you discussed in the previous context. Therefore, Vpc can be written as R into omega. So its direction is quite clear. By using equations 1 and 2, we can write the magnitude of velocity of that point is equal to the magnitude of the sum of these two vectors, and that is equal to Vpc square plus Vc square plus 2 Vpc into VC or dot VC, or 2 into VC into cos of the angle between these two vectors, VC and VC. Suppose this is VC. VPC and VPC, in between these two vectors, the angle let it be theta. Take the square root of this. So VP can be written as, VPC can be written as R omega. So this is R square omega square plus VC square plus 2 VC R omega cos theta, where theta is the angle between the velocity of the point that is given and the velocity of point P with respect to C. This is the theory. If we add these two vectors, which vectors? Velocity of the point C, which is given, and velocity of the point P with respect to C, which is shown here. If we add these two by a parallelogram law of vectors, we can get the direction of the velocity of P. This is the velocity of P. So velocity of P is the vector combination, the vector sum of these two velocities, velocity of the point C and velocity of point P with respect to C. That's equal to R into omega. R is the distance of separation between these 2 points. Using this idea, let us solve a problem. As an example, let us take this rod. This rod has an angular velocity omega is equal to B by L. L is, say, half of the length of the rod. We have 2 points, end points, P and Q. And this angle is given as, say, 30 degree or 60 degree. By using the concept of relative motion, find velocity of the point P and velocity of the point Q, both magnitude and direction. Redrawing this diagram, this is the velocity of C, that is equal to V. This is velocity of Q with respect to C must be perpendicular to QC, because the rod is rotating in anticlockwise sense, and this point P will move with respect to C in opposite direction, having the magnitude L into omega. Yes, magnitude also is equal to L into omega by relative motion method. This is the velocity of C. Bring this vector and attach here. Bring this vector and attach here. We have 2 vectors, VPC and VC. We have 2 vectors, VQC and VC. According to the Galilean transformation, Vp is equal to Vpc plus Vc, and Vq is equal to Vqc plus Vc. If you want to calculate the magnitude, Vpc square plus Vc square plus Vpc into Vc, Vpc and Vc, the angle is, if this is theta, this is 90 minus theta. Theta is 30 degree. Therefore, 90 minus theta is 60 degree. Cos 60 degree. Cos of the angle between these two vectors, Vc and or Vpc dot Vc, you can just write square root of this. Vpc is equal to L into omega, Vqc also is equal to L into omega. Using the concept of relative motion, method of the angular velocity. So, Vpc you can write L into omega square. Vc you can write V square to Vpc, that is L into omega, into Vc, that is V, the angle between these two, dot product, the angle between these two is, the angle between these two, this two vectors Vc and Vpc is equal to 60 degree, cos 60 degree. But omega is V by L, it is given. If you substitute omega V by L, then we can write omega is equal to V by L. So, L omega is equal to V square plus 2V into V into cos 60 degree 1 by 2. So, we are getting root 3 into V answer. If we add these two vectors, we are getting the velocity of the point P, whose magnitude is equal to root 3 into V, and direction, of course, you can get it 30 degree plus 30. This is inclined at an angle of 60 degree with respect to the rod in this direction. Similarly, you can calculate the velocity of the second point Q. Vq is equal to Vq C plus Vc mod Vqc square plus Vc square plus Vqc dot Vc, square root of this. Vqc and Vc, the angle between these two, we need to calculate. When this is 60 degree, this is 60 degree. This is 30, therefore this is 30. So, this is 30 degree. When this is 30 degree, this is 90 degree, this angle is 120 degree. Angle between VQC and VC is 120 degree, and VQC is equal to L omega. L omega is equal to V, because omega is given V by L. So, you can write this VQC as V, VC as V, to VQC, that is V, VC is V. Angle between these two is cos 120 degree, and this is equal to minus 1. So, you are getting V square plus V square 2V square, or you can just write V square plus V square plus 2V square into minus 1 by 2. Cos 120 degree is equal to minus 1 by 2. So, 2 is getting cancelled. There you are getting 1 V square, another V square is getting cancelled. So, ultimately you are getting V. Velocity of Q is equal to V. If you add these two vectors, you are getting the vector in this way. Along this direction, Q moves. Along this direction, P moves. And what is its magnitude? Probably this will be 60 degree. That you can calculate. The angle you can calculate physically, and by using this formula, you can calculate their magnitude of their velocities. That's a beautiful problem. Next section is calculation of acceleration. That's more interesting, and we can use the relative motion method. Even though ground frame method also we can use from time to time. In some problems, ground frame method is more effective. In some problems, relative motion method is more effective. So next context is to find the acceleration of a point of a rigid body.